Hello everyone, welcome to Sangeeta Sirsat channel. In last lecture, I have discussed about the basic concepts of OOP. So in today's video, we will learn about data types, declaration of variable, type compatibility, type casting, reference variable and dynamic initialization of variable. So let's get started. Data types in C++. So data type in C++ is nothing but the type of data which we will use in a program. So C++ provides us with some of the fundamental basic data types like integer, which represents some integer numbers that can be a positive number or it can be a negative number. The second data type is character, which represents a single character and it has to be enclosed in single quotation or double quotations. The next data type is floating point number. So floating point number means decimal points, decimal number. Double data type. Double data type is similar to floating point number, but it gives more precision. Boolean data type. Boolean data type represents Boolean values true or false. Void data type represents the absence of data, that is, it does not return any value. And this void data type is basically used with functions that do not return any kind of value. So these are some of the examples of variables along with the data types: integer, character, float, double and boolean. In this image you can see we have a variable age of data type integer and we have assigned a value 20 to it. Next is declaration of variable. So declaration of variable is nothing but which part of a variable is being declared or introduced before its use. The syntax for declaring a variable is a data type followed by a variable name. Data type can be integer, float, double, character, and the name of variable. Name of variable, we can give any name to the variable. So that is variable declaration. When I am declaring a variable means when I am using the data type along with the variable name, that is what it is, declaring a variable. So before using a particular variable in a program, I need to declare it. I need to give the type of data which I am using in a program. So in this example, this is integer, this is a variable name. So we can say this age variable is of integer type. The second example is character grade, which indicates that this grade variable is of character type. Next is variable can also be initialized at the time of declaration. So in this we are combining two things together into a single statement, declaring also and initializing also. So in this example, int age is nothing but the declaration, means age is of integer type. I have declared the variable age of type integer and I am assigning some value to it. So this value is nothing but the initialization of the variable age. So simultaneously we are declaring also and we are initializing also. Same with the second example, character grade. Grade is of character type of data and I am assigning the value to it as a value. Next, type compatibility. Type compatibility refers to the rule that governs whether value of a different data type can be used together in an expression or in an operation or any kind of assignments. So type compatibility, as the name only indicates, we need to check the compatibility of types, compatibility of data types, whether the data types can go together in an operation, in an expression or any kind of assignment or not, so that it should not give us any type errors. So type compatibility is nothing but checking the type of data, whether it is compatible to another type of data or not. So for doing that, we have typecasting. In typecasting, we have implicit typecasting. Implicit typecasting means the compiler will convert the one type of data into another type of data automatically. That is why implicit typecasting is also known as automatic conversion. So the rule for converting one type of data into another type of data when I am using implicit typecasting is the smaller data type is converted to wider data type. So this work is done by compiler implicitly by its own. We are not writing any kind of code for doing that conversion. That is why it is called as automatic conversion. Take a look at this example. I have an integer type of data, I have a float type of data. After adding this, I am getting a result in float. So in this, I am not telling the compiler I want the result in float. It is automatically getting converted. So that is what implicit typecasting is. Smaller data type is converted to wider data type. Smaller data type converted to wider data type. So next is explicit typecasting. In explicit typecasting, the compiler does not do any kind of conversion automatically. No, we need to write a code, we need to write some sort of statement so that the compiler will forcefully convert one type of data into another type of data. So in this example, I have a variable I which is integer with the value of 20. I have a variable f with the data type float. So if I want to convert this integer into float, I need to write the data type in which I want to convert. I want to convert this I into float number, and I can write like this for conversion float of I. So this two statement will convert integer I variable to float I. That is what explicit typecasting is. I am telling the compiler to forcefully convert integer data to float type of data. The next example is in which I have a variable f with the value 20.55. I am converting that float value into integer value. I am telling the compiler to convert float into integer. So when I print the value of I, it will give me what? 20, as because I have converted f from float to integer, and it is giving me value 20 excluding this decimal. So that is explicit typecasting. In this example, the first example is based on implicit. I have two variables a and b of type integer, float, division. So when I am dividing a number 15.2, I am getting a result in decimal. So that is implicit, that is automatic conversion. As because I have declared it as float, the value of division is float, I am getting the result in float, that is implicit typecasting. The second example shows you implicit as well as explicit typecasting. Explicit typecasting, I have a variable a, I have a variable b of integer type, again a variable divide for double. Here in this statement I am converting a, which is of integer type, to double, that is explicit typecasting. I am telling the compiler to change integer a into double. The next is I have a variable x with the value of a. So when I am performing this, x equal to x plus 3, x is of which type of data? Character type of data. So it will give me value a plus 3 equal to d, that is implicit typecasting. And this is explicit, this is implicit. So in implicit typecasting, the compiler is converting smaller data type into wider data type automatically. In explicit typecasting, I need to tell the compiler to change one type of data into another type of data by writing a statement, by writing a code in a particular program, so that it will get converted to another type. Next is reference variable. Reference variable is a variable which is known as alias. Alias is nothing but alternative name, or you can say another name given to an already existing variable. If I have a variable int a, this is an already existing variable, I need to give this variable an alternative name, or you can say another name. So this I can do with the help of reference variable. The reference variable for a variable can be declared as data type ampersand refer, that is the name of reference variable, you can give any name, and the name of variable. So that is the syntax for declaring reference variable. Take a look at this example. I have a variable hello of data type string with some value initialized to it. Now in the second statement, I have a asterisk pointer of type string which is storing the reference of that variable hello, memory address of hello variable or object. Third is, this is what reference variable. This is my variable which is already existing over here. This reference variable is of type string. So in this example, I have given alternative name to already existing variable. Already existing variable is hello. I have given an alternative name hello underscore ref to the variable hello. So that is what reference variable is. So when we talk about reference variable, that is, I am giving another name to an already existing variable. So if I have an variable with value 10, I have declared an reference variable. An alternative name for x is ref. And when I am changing the value of the reference variable, my value of existing variable is also getting changed. Vice versa, if I am changing the value of existing variable, my value of reference will also get changed. Next is some key characteristics of reference variable. The first one is alias to an existing variable. Alias to an existing variable means giving alternative name to an already existing variable. Initialization. A reference must be initialized at the time of declaration. So, this is my variable. This is my reference variable. I need to initialize it with the already existing variable. This is what initialization is. So, I am declaring a reference variable. This is the declaration of reference variable. So, at the time of declaration of reference variable, it has to be initialized with the already existing variable. No null reference. So, the reference variable should not be null. It has to point, it has to be a valid variable or object. Immutable reference. When I am using a reference variable for a variable, I cannot use the same reference variable to point to another variable. This is wrong. When I have already used a reference variable for any variable, I cannot reuse the same reference variable for B. The next is dynamic initialization of variable. Dynamic initialization of variable is the process of initializing variables at runtime rather than at compile time. So, this type of initialization is useful when the initialization of variable depends upon the user input, or you can say a function call or any condition that can be determined while the program is running. So, dynamic initialization basically occurs during runtime. Runtime is nothing but when actually your program is getting executed. The statements are getting displayed onto the screen, the user is inputting some values, some of the function calls are getting executed. At that time, when the value of a variable is initialized, that is called as dynamic initialization of a variable. Let's look at the example. The first example is dynamic initialization with user input. So we have two variables, length and width. I need to take the value from the user. After taking value from a user, when I am executing this piece of code, or when I am running this piece of code, this particular cout statement will get displayed, and as a user, suppose I will see the statement enter the length and width of rectangle. So I have entered some value for length and a value for width. After that, I have a formula for calculating area. So after calculating this with the value of length and width, I have got the value as 20. That is what dynamic initialization of a variable means. During compile time, I am unaware of the value of area. When I am actually executing this code, I am getting the value of this variable area, and then in the next statement I am displaying the area as 20. In the next example, dynamic initialization with function calls. In this we have a function getNumber which is returning a value 42. I have a variable number of integer type and a getNumber. GetNumber function call will get executed and it will return a number 42 which will get stored in a variable number. So that is dynamic initialization of a number variable which is taking place when a program is getting executed. So this dynamic initialization of a variable is done during runtime. When the program is getting executed, the values for that particular variable is getting initialized. So that is what dynamic initialization of variable is. When we don't know, we are not aware of the values of a particular variable when we are writing a program or we are compiling the program. See, during compile time we just are aware of some syntactical errors, but when I am executing a set of program, executing some set of lines, and during that time if a variable is getting initialized with some value after the computation, so that is what dynamic initialization of a variable which is taking place during runtime and when the program is getting executed. So that's all for today. Thank you.